2019. Read the following passage and answer the questions. Radioactivity of a spontaneous radioactivity of a spontaneous decay process by which an unstable nucleus becomes a stable nucleus by, right. Since the passage is going, right, I'm just skimming through the passage. Right. Just skim through the passage. Right. And if there's any important data, you can highlight. Right. 1 Curie is equal to this, right? Then Curie and Becquerel conversion is given. And then another equation about lambda is given. Right. And okay. Right, I'm just skimming through. And here half-life is given. Half-life time of iodine 131 is 8 days. Okay. Then let's go to the questions. Right, questions are the so as you go with the questions, right? As you go with the questions, you can check the passage, you can skim through the passage. How long is the essay discussion? You mean now? Right, this is the last question we are discussing. State two differences between the emissions of beta and gamma. Right. So we know beta is a particle. And gamma is a electromagnetic wave. That is electromagnetic wave. Right. Then right, mention these differences. Beta is a particle. Beta is a particle. And gamma is an electromagnetic wave, or you can say electromagnetic radiation. That is electromagnetic radiation or electromagnetic wave, you can say. Electromagnetic radiation or electromagnetic wave. Okay. Then two differences. Okay, we need another one. Right, we need another one. So we know about beta. Beta is what has happened? One second. Okay, anyways. iPad is kind of heated. I'm on the charge now. Right, charge again got a screen share kalla Zoom meetings are this heat now. Right, for some reason it has stuck now. Right. Okay, then beta is 0, -1, and gamma is 0, 0. No, gamma is 0, 0. Atomic numbers and mass numbers, that we know. Right, that we know. Then when beta emits, we know with this -1, atomic number changes. Right? And when gamma emits, atomic number is unchanged. That is also a difference, no? Then second difference here is atomic number changes. Atomic number changes when emits. Atomic number changes when emits. And here atomic number remains unchanged when emits. Atomic number remains unchanged when emits. Right. Second one. And also about beta and gamma, you can say gamma is highly penetrative. Penetration of gamma is high. Right. This is high penetration. High penetration. This is low in penetration. Right. You need any two. High penetration and low in penetration. You need any two. Right. Right. Second one, rewrite the following decay equation replacing ABC with correct numbers. Okay. Then iodine 131, 53. Right. Xenon 131, A is given. And beta is a known particle. Beta 0, -1. then 0 minus 1. Balance the equation. Balance the equation. To balance the nuclear equation, right, there should be an equal number of nucleons at both sides, right? Nucleons at both sides. Atomic number represents number of photons here, number of protons here, and mass number represents the addition of sum of protons and neutrons. Then here in this side there are 53 protons. Then to balance this, it must be 54 here. Then 54 minus 1 is 53. And check the mass numbers, 131, that is okay. Then answers for these three are A equals 54, B equals 0, C equals minus 1. Right? Then part B. A fresh sample of sodium 131 iodine having an activity of 100 millicurie is received by a hospital. The sample is stored in a lead container at room temperature. Right? What is the SI unit used for activity? SI unit of activity is becquerel. Right? That's a theory part, no? Becquerels. Right? Becquerels. BQ. Becquerels. Write down an expression for the decay constant lambda in terms of half-life time. A proved equation. Right? That is a proved equation. Right? That is a proved equation. Using half-life time, no? Then lambda equals 0.693 over T half. This is a proved equation. Lambda equals 0.693 over T half. Third one. Or else you can write the same equation as, right? ln2 ln2 over T half. Right? Both are fine. 3. Calculate the activity of above sample after 4 days and express the answer in SI units. Take ln2 as 0.7. Right? Now they have given that 0.693 to take it as 0.7. Right? Now only we can assume that as 0.7. Right? Now we can assume that as 0.7. And e to the power minus 35 is 0.7. Okay. Then after 4 days, no, then we know for activity we have an equation like this. For activity, R equals R naught. We can write it as either R or A. That's fine. R equals R naught e to the power minus lambda t. Right? E to the power minus lambda t. And we need R after how many days? After 4 days. Then R equals R naught is given. R naught was given as 100. No? That is 100. 100. E to the power minus lambda. Lambda is 0.693 over T half. Then 0.7 is given. And T half. What about T half? T half was 8, no? 8 after 4 days. Then R equals 100. Right? E to the power minus. Right? 8 4 means 2 remains. Then 0.35. See, this value is given. 0.7. Then R equals 100 times 0.7. R equals 70. Now this is in millicurie. Right? Now you are asked to convert it into SI, right? SI units again. And the conversion is given. See? 1 curie is equal to 37 times 10 to the power 9 disintegrations per second. Disintegrations per second is called becquerels. Right? Disintegrations per second is becquerels. Right? Then to convert this into becquerels, multiply this with this number. 1 curie again. Then here I have, right, this much of curies, milli. Right? This much of curies. Then R equals 70 milli 10 to the power 3, 37 10 to the power 9. Right? So that is 2.59. 10 to the power 9. Right? Becquerels. 2.59 10 to the power 9 becquerels. Right? Conversion is also given. Right? Okay, 3 is done. Then 4. Right? 4. Hence, express the change in activity as a percentage. Right. Then we know any change is written as final minus initial over initial value, no? Then final value was 70, right? Final value was 70. Then about this, when we write final minus initial, we know these are decay. These are about a decay. Then final value is a less value. Then you are getting a minus sign. To exclude that minus sign for the change, you have to put another minus sign since there is a decay, right? Minus sign means decay. Or else, when it comes to radioactive decay, if you are writing a difference, right, you can consider initial minus final, right? Both fine, right? Both are fine. Then initially it goes 100, no? Finally 70. Initially 100. Then percentage into 100, right? Become simple now. Then what's the change? Change is 30%. Change is 30%. Change is 30%. Change is 30%. Right? 5. Is it possible to reduce the activity of sodium sample if it is stored at 0 degrees Celsius instead of storing at room temperature? Explain your answer. No. Very straightforward, because radioactivity, right? Radioactivity does not depend on any external factors, right? It does not depend on any external factors. It depends only on the initial number of radioactive particles in the sample, right? So simply radioactivity is independent of all the external conditions, right? It is independent of all external conditions. Temperature is also one such condition. Temperature, pressure, wind speed, humidity, right? Nothing. It depends on nothing. Then 5, no. Reason, radioactivity. Radioactivity is independent of external environmental conditions. Right? Next, part C. A small amount of sodium iodine sample having an activity of 100 millicurie is administered into a thyroid patient. First one. The thyroid patient. When dealing with such a patient, for which mode of emission the radiation protection measures should be taken? Explain the answer. For which mode of emission? Right now, we know from here, from the one here, right? In the description it was given, right? See, about penetration length, it is given. About gamma photons and the maximum tissue penetration length of beta is 2 millimeters. The half-life time of right patients of sodium iodide, that is called sodium iodide in the form in a capsule once administered, it's absorbed into the cells. The answer is here in the passage. Yes, most of the considers. Okay. Then compared to beta, right? Compared to beta, gamma has a higher radiation. Compared to beta, gamma has a higher radiation. Then we have to protect from gamma. Because penetration of gamma is high. Then what's the question then? When dealing with, okay, the radiation protection measures should be taken for which mode of emission? Gamma emission. Then gamma emission. Right? Then explain the answer. Explanation is in the description. Maximum penetration is for gamma, and beta has a less penetration, so it won't come out the body sometimes. But gamma comes out. Then explain. penetration of gamma is higher than beta. Penetration of gamma is higher than beta, right? Higher than beta. So that gamma might come out the body. Gamma might come out the body after penetration. Right? So I got this from the passage. Read the passage. Second one, show that the effective half-life time T of iodine 131 in thyroid gland can be given by 1 over T equals, okay. Can you remember that one equation was given for lambda? See, it is given that lambda equals lambda P plus lambda B, no, plus lambda B, right? We know lambda is, 0.693. Oh, it is considered as 0.7 now. Over T half, no? 0.693 over T half. 0.7 over T half. Since we are asked to consider it as 0.7, now we can consider it as 0.7. Then lambda E can be written as 0.7 over TE. Lambda P is 0.7 over TP. Lambda B is 0.7 over TB. This cancels off and this remains. See how easy? 1 over T equals 1 over TB plus 1 over TB. That's it. Right? Easily gettable. Third, if the biological half-life time, that is TB, that is in the passage. If the biological half-life time of iodine is 24 days, calculate the effective half-life time of iodine in days. Right. Now, this was given, listen, see, the half-life time of iodine is 8 days. And somewhere here in the passage it says, corresponding to physical. Then physical half-life time is, right? Physical half-life time is TB, right? Corresponding to lambda B. And biological is B. Then physical is given as 8, no? Physical is given as 8. Then applying the equation equals 1 over physical is 8 and biological is now given as 24. Biological is 24. Simplify. Then 1 over T equals 24. This is 3 plus 1, no? Then T equals 6 days. Right? 6 days. Again, a small calculation. Then fourth one, calculate the percentage change in activity after 4 days of administration of iodine 131. Take e to the power minus 0.46 as, okay. That answer is also given. Similar calculation as we did before, right? We did something similar before also. So, right? Similar calculation as we did before. Right? You have the same idea from the previous calculation also. R equals R naught e to the power minus lambda t. We need R again. Initial value is 100. E to the power minus lambda. Right? Lambda is 0.7 over, right? T half, now half life is 6 days. After 4 days, no? Into 4. Right? After 4 days. Into 4. After 4 days. Right? Simplify this. Now, when you simplify, you should know that now if 0.46 of E is given, you should get that number somewhere. No? Then check that number whether you are getting it. Because if you are getting it, means we are done. Otherwise, if you are not getting it, you are following something wrong. Simple as that. Idea sitting done. So this is 2 and 3, no? Then this is 100 E minus 1.4 over 3. Right? 1.4 over 3. Check that number. 1.4 over 3 should be that given value. 1.4 over 3. Yeah, that is exactly 0.46. 0.466. So 0.466 is given. right? So this is minus 0.46. Nothing to do now. This value is given. What was the value? 0.63. Then this is 100 times 0.63, which means 63 millicurie. 63 millicurie. Calculate the percentage change. Right. Then change again. We did a similar change calculation before also. Then change is given by initially it was 100 minus now it is 63. Initial value is 100 into 100%. 100 cancels off. Right. Then 37%. 37%. Percentage change. Right. See, percentage change is 37. Right. See, again in a no time, in a quick time. See how many marks we have got now. More than 25 marks for the question now. Already taken. More than 25 marks for the question already taken. Right? 5. Around 26, 27 marks are now taken. Right. 5. 5. According to radiation protection regulations, iodine 131 treated patients can be discharged from the hospital when the activity is below or equal to 50 millicurie. 50 millicurie. If the regulation is followed, how long the above iodine 131 treated patient has to kept in the isolation in the hospital before discharging, right? So at once, if you can see it as 100 to 50 means that is half, no, right? Easiest way is this. 100 to 50 means that is half. That is half, right? What is the meaning of half lifetime? Half lifetime is a time it takes to halve the number of uh, nuclei in a radioactive sample. Half lifetime half lifetime is the time it takes to halve the number of nuclei, in a radioactive sample. Then if there is half, then it should take a half lifetime. It should take a half lifetime. Then it should be 6 days. If you didn't get it at once, applying the equation and still you can get the answer if you didn't get it at once. But otherwise you can easily get it just by uh, the half lifetime, the definition of half lifetime. So we know this can be written as R equals R naught to 2 to the power n, right? Make equation then finally this must be 50. Finally this must be 50. In this equation, n is number of half lives. In this equation, n is number of half lives. Then R rho is 100 over 2 to the power n. Simplify. 2 to the power n equals 2. Then 2 means 2 to the power 1. No? It says n equals 1. N here is number of half lives. If anyone who don't know the equation, n is number of half lives. Number of half lives. Right. Then one half life has gone. One half life has gone. Right. So therefore it must be 6 days. One half life of iodine is 6 days, no? 6 days. 6 days. Right. Then how long? 6 days. How long it is? 6 days. According to the radiation, okay. 6 days. Right. So if you didn't use the equation, you can say, right? Equation you have to explain this. If you didn't use the equation, you can say since effective half-life time, since effective half-life time of iodine, 1 second, temperature is very high here, that's why this is stuck. Okay, see, where was I? Now it's visible, no? Right, where was I? Here. Effective half-life, since effective half-life of iodine 131 is 6 days. Right. Since effective half-life of iodine 131 is 6 days. Right. So that's it. That's it about that question also. Right. See, I have discussed 3 essay questions, right, from 3 recent years.